Everyone, and welcome to episode 25 of our space shooter DevVenture. So, in the last episode, we ended where the testing seek behavior scene is back to the way it used to be in a more scalable way. And we talked about how we were going to advance this this testing environment to facilitate even more behaviors and how we can prove that those behaviors are working, right? So I think the next step, of course, would be to move on to something else, right? Like I said before, I want to add an additional enemy into the scene and start working on managing two enemies at the same time or multiple enemies at the same time. And then once that's working, we can start adding things like collision avoidance and so there's a difference between collision avoidance. Let me just show you that. So here's an entire tutorial about collision avoidance. And then there's another one about flee and arrival, right? And so that means that they are different behaviors. And we need to add all of these in, right? All 9 behaviors. So we've got seek, and we've got some of the so-called movement manager in the enemy ship controller node. And I can show you that here, right? So we've got the enemy ship controller. As you can see, it's quite a large class already, right? And it is a class because we put class name in it. So this is quite a large class already, right? So I mean, you can kind of see from the preview on the side here that there are quite a few functions in here too, right? You can see there are quite a few functions listed here, and we're going to have to keep adding to it, of course. So give me 1 second. Okay, so let's open up this one and have a look at what exactly Fernando has explained in his movement manager, because I built my enemy ship controller without actually following this tutorial. So I want to go through this and kind of make sure that what he's referring to is what I'm actually implementing as well. And if I'm missing something, I want to be able to identify that as something that I need to add in, right? So let's just go through this. He's got a default, almost default introduction here, talking about steering behaviors in general, and then focusing on combining these steering forces into so yeah, okay. So as previously discussed, every steering behavior produces a resulting force called a steering force that is added to the velocity vector, and this the direction and magnitude of that force will drive the character, making it move according to a pattern. The general calculation is as follows, and then he goes into the details about this. So he calls the seek function, which of course is in an entirely different tutorial. So steering equals seek, and then steering is truncate, steering, and max force. So for those of you who don't know what truncate means, basically it just means this. So if I go to this one, what it means is if I were to, for example, truncate the value of pi, right? So pi, let's write that down. Pi is approximately, because it can go on forever, 3.1415926 and so on, right? So to truncate something would be to literally just cut off everything from the decimal value, right? So a truncated pi, so calling truncate on pi would just be 3. Okay, that's what truncate means. And let's continue. So calling truncate on steering and max force. So remember, we called the seek function to get the value of steering, right? So we've assigned that to steering, and now we are calling truncate on steering and truncating it to max force. And I don't know what max force is supposed to be. He doesn't go into detail about that. Anyway, then we reassign steering after that to be steering divided by the mass of whatever the thing is. And I guess this is to add momentum, right? And so an object that wants to turn, right, would have to take its mass into account plus the turning force, right? So I want to turn left really quickly, but I have a specific mass that prevents me from turning as quickly as I want because I'm already moving forward with a specific momentum. So that's what this is trying to do, right? It's trying to incorporate mass into the calculation. And then velocity is to truncate velocity plus steering and truncating that to max speed. So there's a lot of variables that he's not actually explaining in this code snippet. And I find this rather frustrating. It's one thing to say something in a very descriptive name, but you should also at least give a description of what exactly you're trying to do, or at least use an example, Anyway, position is position plus velocity, so we're adding velocity to the position. And then since the steering force is a vector, it can be added to any other vector, just like the velocity. Yeah, okay. However, the real magic lies in the fact that you can add several steering forces together, and it's as simple as this. Okay, so he's saying nothing here is basically saying it's a null vector, a zero force magnitude. And then we are adding steering plus seek. So add seek to steering, and then add flee to steering. So this is building on top of the flee tutorial, right? So obviously we would have had to follow on this. Okay, so let's ignore all of this stuff, right? Because this seems almost like a recap. And he must have gone into more detail in previous tutorials. So we are necessarily missing some information here. So I'm not going to go too much into this. The combined steering forces. Okay, so basically this whole thing is about being able to combine steering forces to get a resultant force, right? A resultant vector. So here you go. For example, if you add these two forces together, it's this one plus this one, and you get a resultant force which is 45 degrees as opposed to 90. And then these two will give you straight line. It's the same thing, just rotated 45 degrees, right? And then these three together would give you this one. Because it's multiple vectors combined. So, complex patterns effortlessly. The combination of steering forces will produce extremely complex movement patterns effortlessly. Imagine how hard it would be to write code to make a character seek something, but at the same time avoid a specific area without using vectors and forces. That would require the calculation of distances, areas, paths, graphs, and the like. If things are moving around, all those calculations must be repeated every now and then because the environment changes constantly. With steering behaviors, all forces are dynamic. They are meant to be calculated every game update, so they will naturally and seamlessly react to environment changes. The demo below shows ships that will seek the mouse cursor but will flee the center of the screen, both at the same time. So as you can see over here, there is nothing. And that is because this used to be probably a Flash player of some kind. And that has been removed from basically every browser at this point. So there's nothing to see here. Click to show forces. Nothing. Movement manager. Here's the whole point of the thing we wanted, right? We wanted to see what is this movement manager all about. In order to use several steering behaviors at the same time, in a simple and easy way, a movement manager comes in handy. The idea is to create a so-called black box that can be plugged into any existing entity, making it able to perform those behaviors. The manager has a reference to the entity that it is plugged into, i.e. the host, and the manager will provide the host with a set of methods such as seek and flee. Every time such methods are invoked, the manager updates its internal properties to produce a steering force vector. After the manager processes all invocations, it will add the resulting steering force to the host's velocity vector. This will change the host's velocity vector magnitude and direction according to the active behaviors. The figure below demonstrates this architecture. So you've got a game entity that has a movement manager component, and there are all these behaviors like seek and flee and follow the leader and queue and wander and all of those other ones. And then the movement manager does something to get a resultant force from all of those behaviors and passes that back to the game entity. The game entity goes, oh, okay, we have our heading, and off it goes. And this happens every single tick of the game update. So making things generic. Okay, so this is not necessarily an enemy ship controller the way I thought it is. It could be, but it doesn't have to be. It can be as simple as a finite state machine inside of every entity, every single game entity, like the enemy ship control. Enemy ship. Every enemy ship in the game would have its own movement manager. Right, so let me just demonstrate this. So we would have a scene, something like this. If you have the enemy ship scene, enemy ship, and this is the scene for the enemy ship, then what you would have is all the enemy ship stuff. So all the stuff we had before, all existing nodes. And then additional to that, you would have an additional scene, which would be movement manager. Movement manager dot tscn. Okay, and so now in the movement manager scene, over here, you would need something else. Let's just draw some kind of scope magnifying thing, and then draw a box over here like that. Okay, and then this would be the movement manager scene. So let's zoom in here so I can write it a little bit easier. All right, so trying to be efficient with my letters, only writing with a single stroke every time without lifting up the pen. Just a little challenge for myself, because I know a lot of these characters in the English alphabet or the Latin alphabet require you to lift up your pen, right? So for example, capital E requires you to lift up your pen and draw a line like that, right? And then there's a famous saying to cross the T's and dot the I's, right? So let's try and see if we can't write our characters without needing to so-called cross T's and dot I's. So this is movement manager dot T. I just crossed the T. T S C N. Okay. Now the movement manager is going to have a whole lot of behaviors, right? And we want some kind of controller inside the movement manager that will determine how things are called. And that is usually called a switch, right? So in C++ and Java and C#, and I suppose C as well, there's this thing called a switch. It's basically a more complicated if statement. So if statements go like this. It says if condition, right? then true body, right? Else false body. And when I say body, I mean code body, right? So false code body here and true code body there. But there's only two, right? The other one would be to say else if or elif, right? So in Python and in GDScript, you wouldn't say else space if, you would say elif. And I suppose you'd have to do that. No, that's way too big. So yeah, that's fine. Okay, we'll set this back to 3 and then disable eraser. Right, so then you would have elif here. So elif, and then you'd have elif body underscore 1. And however many elif bodies, right? So you could go all the way down to elif body n and then have an else. And this would be the false body. Now a switch simplifies this by doing the following. Instead of having it like that, just make my cursor visible again. So instead of having it like this, you would do something like so. You would say switch and then some kind of expression, right? So conditional expressions, I'll just say conditional expression. Okay. And then you would have cases, right? So when the conditional expression comes through as a case, you would say case, and then you'd say result, right? So result 1. Then you would have a body. So result 1 body. And you would say the same thing like this. You go case, result 2, and then blah blah underscore 2 underscore body, like this. And you would repeat yourself all the way through until the end, and then you would say else at the bottom, right? I think you'd say else. A bit rusty on switches. I haven't used them in a while. But in Godot Engine, you don't say switch, you say match. It's a small difference, but it is important. So let's just change that from switch to match. It's the same thing, right? So the majority of what I've showed you is the same. It's just instead of saying switch, you would say match, right? And you would match with the condition and you'd have cases. And I think I've already got a match expression somewhere in my code. Let me just look for it by going control find, match, no, match, no, behavior, no, level config, level manager. Aha, here we go. Match. So here, match level condition, level configuration dot win condition. Now instead of saying case, you just say what the case is. So if the level config win condition is the case destroy all, right? And then in this case it is a string, then you would have the body for that case. And similarly, if you have a survive case, then you have a body for the survive case, but we don't have one, we just said pass, right? And you could do this for as many win conditions as there are. So if I go to the top, where did I specify win condition? In level config. Win condition here is of type string, right? So there should be an else. There should be an else statement where you say else this is not a valid win condition or something, right? Because it's a string. The better way to do this, of course, is not to use a string at all, but to use what's called an enum, however you want to pronounce it. Basically, an enumeration. And an enumeration is similar to. I'm going on tangents. Let me not carry on with this this whole line of thinking. Let me just continue with the movement manager, right? So what we want is similar to a match. We want a state machine, right? So you would have all these functions like seek and flee and follow and wander. I realized that I'm not writing my characters with a single stroke like I said I should. So let me do that. Right? So you've got wander and Q. So Q U E U E and so on. And you need something that can call them all in the movement manager with some type of evaluation. So in many games, you'll find that a finite state machine or just state machines are quite common. They are almost a staple of game development. And to manage a state machine in Godot Engine is something I haven't actually done before. I've been meaning to, and I realized quite early on when I started doing the enemy AI that I would have to use a state machine to control it, but I've never actually done one yet. And I think we need to do that now. So if I go to the pirate enemy, for example, here, you'll see that I've got all of these things. So seek, the seek function, really should be in its own. It should be part of the state machine, or at the very least, the state machine should have access to all of these functions like seek and flee and patrol and whatever else, right? So just checking something. All right. I've got weird outputs. Renderer scene cull. Indexing did not unpair geometries from the light. Oh, okay. So this is complaining because in the testing seek behavior, I turned off the gizmos for the lights so that it's easier to see all the things in the scene, right? So you can see here's the gizmo for the camera, but the gizmos for the lights are off. So if I go view, gizmos, light 3D, you can see I've hidden them. But if I unhide them, you can't even see the enemy pirate anymore. He's just buried in all these light icons until I zoom in and then you realize, oh, look, there's an enemy pirate ship here. And he happens to have lights in certain points. But as soon as you zoom out, it's literally just light gizmos everywhere. And when I turned the gizmos off, these are the error messages I got. So now you know. Okay? I want to make a finite state machine for enemy ship behavior. How do I do this? Let's look through this whole thing. So we've got the lights for the wing thrusters and the tail thruster lights. They're all here. And then we've got the gun. So I just want to open up the gun scene because when I go to scenes, components, what is this called? Gun pirate. It should be called gun NPC. It is gun NPC. Okay, so let's open up gun NPC. And if we open up this, you'll see that this is not part of any group. And neither are... Yeah, there we go. That's the problem. You see, I've labeled these as part of enemy ship, but they are not part of enemy ship. They are components. And so they should not be labeled as enemy ships. So when I run my testing seek behavior now, you'll see that error message at the end we had last time isn't there anymore. Let's just run the scene. We'll check the output. And then as soon as it reaches that waypoint, we'll close things down. Okay? Here we go. We should have no error messages until it starts moving. And we don't. Perfect. That means everything was initialized correctly. And it was literally just because in the gun NPC class or scene, I had labeled these things as part of enemy ship when I shouldn't have. Okay, problem solved. Moving on. I want to make a component for the enemy ship that is a finite state machine. Alright. So let's just think about this for a second. I want to make a new drawing so that we can have a clean canvas on which to scribble. Right? I'm just thinking this through. Okay. So ideally, you would want to isolate each behavior into its own script, right? So you'd have a seek script. Because again, it is that whole principle I mentioned before, right? The whole dry principle, which is do not repeat yourself. Or don't repeat yourself. Otherwise it would be DNRY. Here we go. So you've got dry. This way. Don't repeat yourself. No, that's a bad looking F. Let's try that again. Don't repeat yourself. Okay, so if I'm making a seek function, and what I mean, you'll see what I'm trying to do here when I actually demonstrate this in my drawing. So if I change the color now to green, for example, and then I make a thing like this, right? And instead of having it like this, so let's say I have this as my NPC defender, right? So we'll say NPC underscore defender. Messed up that F there, but okay, fine. We'll just keep going. Defender. Okay, and the NPC defender has its own seek function in its script, right? Then it's got a seek function. And it's got a flee function. And it's got a wander function. and so on. And I do the same thing for my pirate, and I do the same thing for my miner, and I do the same thing for all my NPC things. You see how this becomes a problem, right? Because this seek function isn't necessarily the same as the pirate's one or the miner's one, but I'm going to write it out just so that it's on the record for the next time we do something. Change the color to yellow or orange for the mining vessel. Okay, so we go NPC miner. And then this has also got its own seek function and its own flee function and its own wander function and so on. And maybe it's got its own custom ones, right? Like ping and mine, like actually mine, and to what I'm going to call home, right? To go back to the capital ship and to offload the cargo before going out again and filling up its capacity and repeating, right? And then we've got the other class, which is the pirate class. So we'll just do this. Oh, didn't change the color. So let's do that like so. And then we'll write this out. So NPC pirate. If you have any ideas on how to do an I without having to dot the I in a single stroke, let me know. That's one of the few letters that I can't actually do, like an I and a J. It's very difficult to think of a way to do it without having to dot the I and the J. But yeah, anyway, so we've got seek and flee. So I can do an F without needing to cross it. It just doesn't look the same. And then wander, wander like this. So now you can see that I've got three functions, right? And each of them are not the same necessarily, right? Because this one is a green, green seek. This one is a yellow seek. This one is a red seek. And they have maybe the same behavior, maybe they have different behaviors, but that's not good, right? Ideally, we want them all to be the same. Don't repeat yourself. So what you actually want is you want your own seek scene, or at least a node with a script attached to it, right? That is separate, independent of any of these entities. It should be a component, right? And so what you want to do is you want to make a white box, white for not 2D and not 3D node, not even a UI node. Because here, if you go to Godot Engine and you check on adding a scene, or rather adding a child node, you'll see here, right, that you've got control nodes, which are green, you've got 2D nodes, which are blue, and you've got 3D nodes, which are red. But there's also just an ordinary node, which is white. And what you want to do is you want to just add an ordinary node, because it's not supposed to take up space in 3D or 2D. It's not supposed to have any impact on your GUI. It's just supposed to be a placeholder, and you attach a script to it. So here you can see the health component has a white ring to show that it's just an ordinary node with a health.gd attached to it, right? So we want a similar thing for our behaviors. So if I go back to Krita, we want a seek entity, right? So we'll go behavior, I should have started on the top. Behavior seek. Okay, and this should have its seek .gd script, and that's it. Okay, and we repeat this for all the behaviors, right? So we'll repeat this for flee. So we'll say flee, and that's behavior underscore flee, and this one has flee.gd attached to it. Excuse the very bad handwriting there. I was too far out. I should have just zoomed in a little more. We'll change that back to 3 pixels, and now we'll write this properly, right? So turn off eraser, flee.gd. All right, and we repeat this process for as many behaviors as there are, right? So blah blah blah, and then for each of those, just switch back to my mouse. Yeah, so for each of these guys, you would then add in these entities. So then they would be added in as separate components. But ideally, what you'd actually want is you would want a containing entity, right? So you'd want an NPC behavior manager of some kind. So let's draw that out. Something like this. And each of these would be added to it. So you'd have each of those would come in to this entity at the bottom here. And I will just write the name at the bottom so it's easier to read. It would become something like NPC behavior manager. So NPC steering manager. And what that would look like in Godot Engine is you would have the NPC steering manager as a normal node. So it would be NPC steering manager. Okay. And then as a subset of those, you would have separate nodes inside these for each behavior. So you would have behavior seek and behavior flee and behavior wonder and so on. And then you'd literally just add this component to each of these guys, right? And the behavior will be exactly the same, right? And you might even have in here, you'd have for these, you would have specialized functions included, right? In the steering manager, and then just enable or disable depending on which group the NPC belongs to. So if this particular NPC entity belongs to the group of mining vessel, right? For example, if it's part of the mining vessel group, then it has access to the specialized functions of, like mine and ping and maybe the other guys don't have queue because they don't need to queue, right? But the mining vessel does, because if there are multiple mining vessels all coming into the capital ship at the same time to offload their cargo, you'd want them to queue, right? Because there's only maybe one or two or however many dispatch locations where you can actually offload your cargo. And so the mining vessels would then line up and get processed one after the other. But this behavior, you don't want that for the defender. You don't want that for the mining, for the pirate, for example. And so you would have to have a specialized check. If this thing that, if this entity has a group tag for mining vessel, then we enable those functions. And you would have functions like shoot, maybe not shoot, chase, the opposite of flee, which is to chase. And maybe chase is slightly different to seek, because well, no, actually, no, never mind. But like patrol, does a mining vessel really need to patrol? Surely a military vessel like a defender or a pirate would want to patrol, right? A pirate would be patrolling for potential prey, right? Patrolling for the next mining vessel to attack, or patrolling for any threats like defenders that happen to be in the area, so that it can make sure that those defenders won't be around when the time comes to strike against the mining vessel. And then similarly for the defender, the opposite, right? So a defender would be on patrol for pirates, actively patrolling for them. And if a pirate happens to come or be discovered while on patrol, then attack the thing, take him down. Because if you take him down before he starts attacking a mining vessel, that's less risk later, right? Because any moment a pirate is attacking a mining vessel is a risk that they will actually succeed at destroying the mining vessel, or at least damaging it and weakening it and making it more vulnerable to future attacks. So there's all that to consider. And so you'd have these like checks for each of them, right? Does this behavior work for all NPCs, or is it specific to a subset, right? Is it only for the pirates and the defenders and not the mining vessel? Or is it only for the mining vessel and not the others? And so you'd have to check, like, if it's part of this group or this group, then allow that. And if it's not, then don't allow it. And so on. So I hope that made sense to all of you. So actually, let me check. Please, if you don't mind writing in the comments, if you are able to follow along with what I've said, and if you found my explanations helpful. If not, then I will try to reduce these explanations in future. But I do need to think these things through myself. And if you think that this isn't helpful to you, then I'll do it off screen. I'll just do it in between live streams. But if you do find this helpful, then please do let me know. I'll continue in the meantime. So we want to make these entities now. Let's begin by making our first component. Sorry, not entities, components. They are components. I want to make a new component called I want to put these in folders, but as soon as I do, it's gonna mess up the folder paths and the file paths in all my scripts, and that's a bit of an annoyance. So let's say a new scene, open. No, I want to make a new scene. So let's components, create a new scene. And we'll call this, it will just be an ordinary node. We'll call this NPC steering behaviors or steering manager, like I wrote in the steering manager. And then in the steering manager, we'll have one for each behavior, right? So components, and there are scripts for the behaviors. So what if I make a folder for all my movements? So I'll call these steering behaviors. So in components, create a new folder. We'll call this steering, lowercase, steering, 2 E's, behaviors. Okay, and then in steering behaviors, we'll add scripts. Actually, no, we'll create scenes that have the scripts attached. So this will be the seek scene. So we'll add a new scene, which will be of type node. We'll call this seek.tscn. And attached to seek.tscn, we will make the node. So we will add a node here. I'm in the script. So behaviors. So let's add a new folder here, and we'll call this steering behaviors. Steering behaviors. Behavior scripts. Just to disambiguate from the other folder we have up here, which is steering behaviors. So this is steering behavior scripts. And in this folder, we can create a new script. We'll call this the seek script. So it'll be seek.gd. And in seek.gd, we will take the logic from here in enemy ship behavior. We'll just take this script and we'll take this out and move it into a new script, right? But we can't just copy and paste it into another script because there are variables and dependencies and all kinds of things in here that we'll need to manage. And so now let's go through this and find out, what do we need to do? What do we need to do to make sure that this migrates successfully into our seek script, right? So we've got a variable here, direction to target. We've got a variable called target rotation and a variable called current rotation, right? And all of these are being declared inside the seek function. So that's good. We don't have to worry about dependencies in that sense, where there's a variable we are using outside of the scope of this function, which is perfect, right? That means we can take this and dump it in, well, not dump it, but move it across to actually, no, we can't, because current velocity and top speed are properties up here. You see, we've got current velocity over there and we've got top speed over there. So we can't actually do that. So this is going to be a little bit more work than I originally thought, but that's okay. It's usually never that simple, is it? So let's figure this out. We'll just deal with it. We'll take it one part after the next, one step at a time, right? So What are these warnings? Unused parameters, delta and direction to target. I see. That's a very strange thing, that we've got this variable called direction to target which we are calculating, but we are not using. Okay. What is this? The shoot function. I'm just thinking this through. Here's my line of thought so far. So we've got three entities, right? We've got the enemy ship itself, so that's the pirate ship. This is enemy pirate. What is that? What we called it? Enemy pirate, right? Pirate enemy. Okay, same thing, different order. So we've got pirate enemy here. And then we've got our NPC steering manager. That's NPC steering manager. You know what? I'm not going to write out their full names because I need the space for my arrow logic, or whatever you call it, flow diagram. So let's draw these out with more space between them. So we have, what I'm trying to do is one of these things again, down here, right? And I don't have a lot of space left over, and I don't want to pollute this drawing because it's nice and neat. So we'll just use this one again, right? And so what I'll do here is I'll go zooming right in and write very, very, very small. We'll say pirate enemy. Turn off eraser. No, make it a red pen. Okay, so that's pirate. Enemy. Okay, that's not bad. And then we'll do the other ones here. So we'll make white for the NPC steering behavior. Okay, and then we'll just zoom in all the way down. And we'll change this to be 1 pixel instead of 3, so that it's even in P. Maybe not 1 pixel. Let's try 2 instead. Okay, so that's NPC steering. Wow, that's bad. Steering behavior. Behaviors. It's not actually that bad. And then we'll make another one over here for seek, because we want to see the dynamics between the 3 of these, right? So let's draw another one. We'll draw a green node. No, but it can't be green because it's white. It has to be an ordinary node, not a control node. Okay, let's just do that. We'll make this 3 pixels again, and then we'll just draw another node over here. Nope, that's way too big. Okay, and then we'll zoom right down to something like this, and we'll call this the seek node. Behavior, nope, we'll just say seek. And then erase. That one. Switch back to pin. That's better. Okay, so now the pirate enemy has this thing, and this thing should run on its own. So on ready, we want to call this thing to start. And we send a signal across like so, telling this guy begin, right? So if I turn the canvas like this, we basically just want to say I've started. Maybe 2 pixels instead. So say something like I've started. And then we'll just erase that there. Something like that. Yeah, okay. That's better. We'll shift this over like so, bring it back to 0. Okay. So the pirate enemy says, okay, I've started. Now the real communication begins, right? This thing, the steering behaviors node, has to tell seek when to seek. But how does it know when to seek, or how does it know any of those stuff, right? It needs to know these values. So if I go to seek here, for example, it needs to know the current velocity. It needs to know what the current speed of the pirate enemy is. It needs to know what the top speed value is, and it needs to know what the current velocity is, and it needs to be able to call, move, and slide, and all of these things, right? So ideally, what you'd want is that seek should return something. Instead of calling set velocity, you should return the current velocity at the end, right? And then once you call seek, you get that velocity and you set that velocity with the result of seek. And then you call move and slide. And that would be fine because you can do that from here, from within the, the pirate enemy. And yeah, that's fine. This should actually be enemy ship. Do we want to make it such that the enemy ship behaves the same regardless of whether it is a pirate or a defender? Or do you, or do we want it to be a separate class for each? So to be type enemy defender, type enemy pirate, type enemy miner, and then have specialized controls for each. Because otherwise, why not just call it NPC ship? No, but it has to be enemy because we want an ally ship class too, right? Because if you're playing as a miner, then you have an ally defender, and if you're playing as a defender, you have ally miners, and if you're playing as a pirate, you have fellow pirate allies. And so you do need a difference between an enemy and an ally. But I see now that we've already gone over an hour, so I'm going to close things off here. I hope that my diagrams have been making sense so far, and that I haven't been just scribbling for myself, that you are able, actually able to follow me. But thank you so much for your time and for your attention. And a big shout out to our junior DevVenture, Cubes. Thank you for your support. And to the rest of you,